हेलो बच्चों। तो आज अपन लोग अपनी फ्रिक्वेंटली आस्क्ड क्वेश्चंस की सीरीज को कंटिन्यू करते हुए एक और क्वेश्चन करेंगे। सो दिस क्वेश्चन कम्स फ्रॉम द चैप्टर थर्मोडायनेमिक्स। अगेन अ वेरी इंपॉर्टेंट क्वेश्चन। और इस क्वेश्चन की खास बात यह है कि दिस क्वेश्चन हैज़ बीन आस्क्ड एवरी ऑल्टरनेट ईयर इन जेई। सो यू कैन ऑल्सो एक्सपेक्ट द सेम क्वेश्चन when you will sit for your exam. So again the same thing, listening is more important than writing. So firstly listen to the video. Don't worry about the notes. I will provide the detailed solution and this chart in the description box and in the comment section also, so you can take it down from there. But first listen. So this question is about thermodynamics, and this question is about the cycles mainly which you study in thermodynamics. So if you know the cycles, then this question would be a cupcake for you. But if you don't know, then listen to me. I will clearly explain this question and you will get to know more. And because these kind of questions are very common in thermodynamics, so this question is quite important. So let us start the solution. So firstly write what is given to us. So let me make it a little. Okay. So they are saying 3 moles of an ideal gas. So N is given to us as 3 at a Cp of 7R/2 at initial pressure Pa and temperature Ta is isothermally expanded. So isothermally means at a constant temperature. So if you don't know, then isothermally means temperature is constant, as we can see here also, constant temperature. So this chart is quite important. I will post this chart in the description box and comment sections, so you can take it down from there. So firstly, there are 3 steps in this question. Very firstly, we have done isothermal expansion and my volume is expanded from V to 2V. Then it is then compressed at constant pressure to its original volume. So my next step is isobaric, which is at constant pressure, and it is compressed back to its original volume. So again 2V is gone to V. Then finally gas is compressed at constant volume to its original pressure Pa. So last step is constant volume, which is isochoric. So in this step we have gone to our original pressure Pa. So we started Pa here. In this isothermal process this might have changed. In isochoric process we get back to original pressure. So let's say change to Pb. So in this step we go back from Pb to Pa. In this step pressure will remain constant because this is an isobaric process. Okay. Now we need to sketch PV and PT diagrams. So these PV and PT diagrams are very common. They will give you 4 options and they will ask you which of the 4 options gives the PV and PT diagram for this question. So listen it carefully how to draw this. So let me start with PV diagram. Let me take my pressure on y-axis and volume on x-axis. So initially pressure is here Pa, and let's say initial volume is Va. Cool. So from this point we have isothermally expanded it to 2V. So let me write ideal gas equation. PV equals nRT. Okay. So PV equals nRT, temperature is constant, R is a gas constant, so it is also constant, and N is number of moles. So I can simply write PV equal to constant, which means P is inversely proportional to V. If you have read geometry in maths, then you must be knowing that this is a hyperbolic equation. And hyperbola curve is something like this. So I will isothermally expand it to volume 2V. Let's say this is my 2V. Okay. Then next process is isobaric. So pressure, let's say this is PB. So at constant pressure, we come back to V. So this is my initial volume. So we come back to this volume at constant pressure, which means a straight line. Then final process is isochoric. At constant volume, we go back to PA. So from PB, we go back to PA at constant volume. Okay. So my process is like this. So drawing PV diagram was simple. You just need to know that this is an equation of hyperbola. So you must draw it something like this. Then at constant pressure there would be straight line, and at constant volume there would be straight line. So this was simple PV diagram for this part. Let's come on to PT diagram. Again same thing. Let me take pressure on x-axis, y-axis sorry, and temperature on x-axis. Cool. So initial pressure is PA. So let initial pressure be PA and initial temperature be T. So again, PV equals nRT. This is a constant. So PV equals constant. Since it is a temperature constant equation, so it would be again a straight line because temperature is constant. But now you need to know that whether we have to draw like this or this. Since P is inversely proportional to V, which means if V will increase, then pressure should decrease. Cool. So let's say initial pressure is PA, initial temperature is TA. Sorry. Okay. So at this, we will come from here to this point. Why a straight line? Because temperature is constant at TA and pressure is decreasing because volume is increasing. So this is my isothermal process where my volume is increasing from V to 2V. Then my next process is isobaric. So again it would be a straight line, but volume is decreasing from 2V to V. So again let me write the gas equation. PV equals nRT. So in this process P is constant. So V is directly proportional to T, which means it would be a straight line equation. But since volume is decreasing, so temperature will also decrease. Because volume is decreasing, then temperature will also decrease, and it would be a straight line, which means I should go like this. Okay, so let us do one thing. Let us shift this diagram a bit. So let us start from here. Let's say this is TA. So I will come like this. Cool. Then since volume is decreasing, so temperature will also decrease. So temperature will decrease like this. Pressure will remain constant because it is an isochoric process, isobaric process. So pressure will remain constant and temperature would decrease. So it would be something like this. Cool. Now final process is isochoric, which means constant volume pressure, constant volume process. And in this process, again we will apply PV equals nRT. So in this process V is constant, so P is directly proportional to T. This is for isochoric process. Okay, so P is directly proportional to T and our pressure is going back to PA, which means we are going back from this point to this point. So which means I need to go back to here. And now how would my curve look like? Since P is directly proportional to T, it means this again would be an equation of straight line. Just go by geometry. P is directly proportional to T, like Y is directly proportional to X. So Y is equal to mx plus C. So it would be equation of straight line. So just draw a straight line joining these 2 points. Cool. So simply you have drawn both the diagrams. So just go by the geometry. अगर अपन लोग ज्योमेट्री से चलेंगे देन दिस क्वेश्चन वुड बी वेरी सिंपल. So when you will go like this, then you can easily draw graph for any type of question, whether it be PV graph, whether it be PT graph. This drawing is very simple. So now let's move on to part number B. So in part number B, they are asking us to calculate the net work done by the gas and the net heat supplied to the gas during the complete process. So moving with the same as done in part A, now we have to calculate work done. So for work done, we know that we can do it like this, like we can calculate individual work for each process and then we can simply add it. तो अपन लोग ऐसा करते हैं कि इसको W1 प्लस W2 प्लस W3 के फॉर्म में लिख लेते हैं, वेयर माई W1 विल रिप्रेजेंट वर्क डन फॉर आइसोथर्मल प्रोसेस. सो आइसोथर्मल के लिए अपने को पता है अपनी इक्वेशन nRT लॉन V2 बाई V1 होती है. सो इट वुड बी nRT लॉन V2 बाई V1, दैट इज 2.303 nRT log V2 बाई V1. ओके, सो यहाँ से अपन लिख सकते हैं 2.303 टाइम्स नंबर ऑफ मोल्स आर 3 RT log volume is doubled in first step, so it would be 2V by V. So my answer would be 2.303 times 3 times log 2 into RT. So when you will solve this, this will come to be approx 2.08 RT. So this is the work done in isothermal process. Now we can calculate W2, which is my work done in second process, which is at constant pressure. So it is isobaric. Okay, and for isobaric process, work done is P times V2 minus V1. So I can write P V2 minus V1. Now I can replace it with nRT from ideal gas. So it would be nRT2 minus nRT1. That would be 3R T2 minus T1. Now in second process, volume is going from 2V to V, and we know that PV equals nRT. Since P is constant, so V is directly proportional to T. So since volume is becoming half, so my temperature will also become half. So it would be 3R T by 2 minus T. That would be minus 3R T by 2. Okay, and third process is my isochoric. But in isochoric process, we know that net work done is 0. Why? Because volume is constant, and constant volume work is always 0, we all know, because work done is under the PV curve. Since volume is constant, so area under PV curve would be 0. So W3 would be 0. So net work done would be 2.08 RT minus 1.5 RT plus 0. So this would be approximately 0.58 RT. This is my answer for the net work done. Simple. Now I need to calculate heat supply to the gas. So I can apply simply the first law of thermodynamics. But before applying first law, I need to check that my process is cyclic. Why cyclic? You can see it from PV diagram or PT diagram. In both the diagrams, we are coming back to the same point. So since we are coming back to the same point, it means our process is cyclic, as I wrote it here also. So in a cyclic process, I can say delta U would be 0. Why? Because delta U is a state function. And for a state function, the property depends on that state only. Since we are coming back to the previous state, so net change in delta U would be 0, because U2 minus U1 and U1 is equal to U2, which is 0. So net work done by the gas would be equal to net heat supplied to the gas. So it would be equal to 0.58 RT. Got my point? This is because our internal energy remains constant in a cyclic process. So since internal energy remains constant, so net work done by the gas would be equal to net heat supplied to the gas, that is equal to 0.58 RT. So again I would say the same thing. The question was simple if you know these basic processes: isothermal, isochoric, isobaric and adiabatic. If you know the PV curves, if you know that for isothermal process the curve is of hyperbolic nature, then you can easily solve for this question. Even if you don't know these curves, then you can simply use geometry and solve all the curves. This table is quite important, so I will leave this table in the description box below. You can take it from there. So if you like the content, then please subscribe the channel, and we will meet again in the next video with some more concepts from frequently asked questions.